Okay, part B. As usual, please, if you have not already read this through thoroughly and even thought about it or attempted it, please pause now and do just that. Alright, now that you've hopefully done that, let's see how this is done. Now, fair warning, I'm going to go very much above and beyond with this one, okay? I'll pretty much cut to the chase about how to just get the answer or an answer. But I'm going to really elaborate, and it's kind of good time well spent. You know, it's time well spent. Because a lot of really important key concepts can get reviewed looking at this problem from different angles, okay? And if you hear that music in the background, that is Truman Show, the movie Truman Show soundtrack music. Anyway, here we go. So I think the big main idea with Part B is that they want you to understand that a number of lawns mowed and a number of yards raked. It's kind of like, well, what would be a number of lawns and a number of yards that would basically plug in to make Tammy's inequality not true, but Keith's inequality true. So in a way, it's like they want you to figure out a solution to Keith's inequality that would not also solve Tammy's. Okay? And really, I think it's just going to be a matter of guessing and checking. So for example, if we decided to go with something kind of ridiculous, I guess, like 200 mowings and 100 rakings. Obviously, if we plug that in, 10 times 200 plus 5 times 100, okay, would that get Tammy's goal of $200? I mean, definitely, because that would be $2,000 plus $500, which, when you add those together, you get $2,500, and that's definitely larger than 200. And if you also plug it in to Keith's inequality, 200 mowings and 100 rakings, to see if that's going to get him more than $180. Definitely, again, because this would be $2,400 here and another $300 here, and when you add those together, you get $2,700. So again, starting like super ridiculously high, a number of lawns and yards, that would have both of them reach their goal, okay? So again, we're just kind of guessing and checking different values. So not 200, 100, that's not going to cut it. So I don't know, maybe you kind of guess and check and you choose, well, maybe we could try 10 mowings and 21 rakings, and maybe try to like narrow in on it a little bit. So if you plugged that in, well, actually, I think the idea might be, well, maybe we could obviously want to figure out something that would work for Keith, but hopefully not work for Tammy. So we have like 12 times 10, and then 3 times 21. That's going to be 120. That's going to be 63. So that would end up getting Keith over 180. But let's see if it also, fails for Tammy, because we want a combination of numbers that's going to have Keith succeed, but Tammy fail. And so if we plug that in for Tammy, we'd get 100 here. But, oh, we'd get 105 there. That would put her over the 200 mark. So, no, 1021. Also not going to cut it. Okay. What if we tried something like 350? So 3 mowings and 50 rakings, because that would be $36 there and $150 there. So that would work for Keith. Let's hope it fails for Tammy. 10 times 3 plus 5 times 50. That would be 30. That would be 200. Oh, man. So, man, okay. So this could actually be, I mean, I think this is the method that would make the most sense to most students. But it can be pretty frustrating, okay? And eventually you might fall on or come around to something like 12, 15. So we would plug 12 in for X as the number of mowings, and we would plug 15 in for Y as the number of rakings, and that would get me $144 there plus $45 there. Okay, so that puts me over 180. And then over here, this, we are hoping it's going to fail for Tammy. So that's $120 there plus $75 there, and that gets us to $195. So there we go. 12, 15, or in other words, if they both did 12 mowed lawns and 15 yards raked, that would be an answer that they're looking for. Such an answer such that it would have Keith reach his goal, but Tammy would not reach her goal. All right, so look, maybe you realize already that there might be more answers that are correct, and you're right. 12 and 15, that's not the only combination that would do the trick here. But I think that's the method I'm going to, I guess, get out of the way first. It's pretty much a guessing and checking method, okay? But look, I'm going to go above and beyond here. And I think it's really, really, really good. I think it'll be time well spent, like I said. And I'm going to start talking about the graphs of these two inequalities. Because remember, when we're talking about all of the pairs of numbers that would satisfy Keith's inequality, that should show up on the graph. When we graph this, there's going to be shading, and we're going to be shading in all kinds of answers that would work for Keith. And then we could make Tammy's graph, and anything we shade on Tammy's graph would be anything that would work for Tammy. So if we were to graph these two inequalities, we'd have literally a picture of all of the combinations that work for Keith and all the combinations that work for Tammy. And along the way, we get to review a lot of key things. So going into this graph, and let's make Keith's inequality a different color, blue, so we can better tell them apart. So with Tammy, okay, if we're going to graph this, we're going to have to get Y by itself. This is definitely a skill that you have to know for the keystones, I would say. So we want to get Y by itself, and in order to do that, first thing we're going to do is move the 10x term out of there. Remember, we want Y to be the only thing. We want that Y variable to stay where it's at, and we want it to be the only thing on that side of the inequality symbol. Okay? So we're going to get rid of the 5 eventually. We want that 5 out of there too, leaving the Y behind. But the first thing you have to do is move the 10x term out of there. So that's going to leave 5y still over there. And then 200 minus 10x, okay? This is something you got to understand. It's just a little intricate detail. 200 minus 10x. Well, guess what? Those don't mix. You can't do 200 minus 10x. They're not like terms. So we're going to leave those terms separate. And, in the interest of putting it in true mx plus b form. Let's put this minus 10x term first, followed by the plus 200. And like I hinted at a little earlier, now we're going to divide both sides by 5 in order to get y by itself, okay? And remember, another intricate detail, remember when you're dividing both sides by 5 and you're dividing the right side by 5, you divide both of those terms by 5. So it's negative 10x divided by 5, which, you know, negative 10 divided by 5, that's clean. And so that'll be negative 2 along with the x. And then 200, we also do 200 divided by 5, and that is going to be 40, I believe. Okay? And then we'll do Keith's really quick, and it's going to be the same process, okay? I don't want to have to re-explain this and slow it down, so let's just show you the same exact process over here. And so for Keith's, when we solve for y, because again, I don't think I said this yet in this part of the video, but another key thing with graphing these linear inequalities or linear equations, you want y by itself because it's all about y being on one side and mx plus b being on the other. If you get y by itself, you can literally see in the equation or inequality what m was going to be for your slope and what b is going to be, and that's your y-intercept. So anyway, let's try to get here. All right. So again, like I'm really getting, you know, it's really getting complicated here with like drawing a crazy graph or having some graph paper and even scaling it all weird. I know, but as I said, the whole idea is let's just look at the graphs and try to remember, you know, that when you graph a linear inequality, you're just drawing a picture of all the solutions. So here we go. To graph Tammy's, remember our b value is 40, and that is our y-intercept. So we plot that, and then our slope, our m, is negative 2, which, remember, slope is defined as rise over run. It's best as a fraction. So negative 2 as a fraction, we just make it negative 2 over 1. All right, sorry, I'm rushing here, but I mean, like, if you need to pause the video or click it back a few seconds or something every now and then, that's fine. So moving on here. With the way this graph is scaled, and it was kind of a necessity, like a necessary evil, again, that's why the guessing and checking method, which we already got done with, probably was the way to go. It was probably what the keystone makers, the test makers, had in mind for this problem. But again, I'm going like really above and beyond here. So we have to now draw a line with a slope of negative 2 over 1. Remember, rise over run. So the negative 2 would represent the rise. So it's like we want to go down 2, and positive 1 would be the run, so we'd go to the right. But how can we do it when it's scaled like this? Well, if you're extra clever, you can think of this as, well, what if I thought of it as going down 10 over what? Like, think about that to yourself. Going down 2 over 1, that fraction anyway, that would be equivalent to what? Going down 10 over what? Well, 5. Okay? So maybe we could go down 10 over 5, which is the same thing as going down 2 over 1. All right, now remember, again, we're reviewing a lot of good stuff here. When you graph a linear inequality, you start with the line, that's what we're doing. You start with the line, and sometimes you have to make it dashed. When do you make this dashed? You know, I'm going to go down 10 over 5 again, just because. And then you know what? Why not? Down 10. I want to make my line, you know, as straight as possible. And so, as to review another good thing, you make your line dashed in these graphs when you have a strictly greater than or strictly less than, as opposed to greater than or equal to, or less than or equal to, and that's when you'd have a solid line, okay? But look, also with these things, you need to shade. And if it's a greater than, we're going to be shading above. Okay, so here's Tammy's. And we're pretty much shading in all of the possible answers that would work for Tammy. Like these are the ones, all these combinations that live in the shading, these would work for Tammy. Okay, now let's go ahead and graph Keith's. So, whoa. I just realized, I don't know what happened. Kind of embarrassing. I'm not sure what happened, but maybe you've noticed this already. Kudos to you, but this should actually be a 60. And so now we can actually graph this correctly. So that's going to be a 60 as my B value for Keith, okay? Oh my gosh, I'm having a nightmare. And his M value, his slope value is going to be -4, which again, it's best as rise over run, so -4/1. So look, how can we make -4/1 really doable on this weird, crazy scaled XY plane here, okay? Long story short, we can make it into like -20, like instead of going down 4, like what is that on this graph? Going down 4/1. But maybe if we go down 20 over what? Over 5. Down 20 over 5, down another 20 over another 5, down another 20 over another 5. And think about this, is Keith's line going to be also dashed, or is it going to be solid? It's just a greater than, okay? If it was greater than or equal to, it'd be solid, but it's not, so we make it a dashed. Which means, I know I'm just keep on reviewing miscellaneous good stuff. That means like any point on that dashed line is not actually a solution. Okay? Anyway, trying to cut to the chase here. Keith's is also a greater than, and so I wanted the different color. So quick redo. So here would be a lot of combinations that work for Keith. Okay, like everything above his blue dashed line. Okay, so trying to tie a ribbon here on this. What you'd be really looking for is, and how to, let's kind of wrap this up. If you're looking at anything in the double shading, like any one of these combinations of lawns and yards, if they're in both of the shading, they would solve both of the inequalities, you know? So let's say they would have asked for a combination of lawns that would have like worked for both of them and have them both reach their goal. Anything in the double shading, you know, anything that's only in Tammy's shading and not in Keith's shading, you know, like a point like this, you know, like what is that, 1,45, you know, that would have been a combination of lawns and yards that would have worked for only Tammy. But this question was asking about points over here where it would have been in Keith's shaded area but not Tammy's. Okay?